The webinar is now live.
Yes. Thank you, Jitesh. Supriya, can we join in? We have 3 minutes to go, but it's already streaming live on YouTube.
Sorry, I'll just share my screen. Fine, right?
Yeah, it's visible. So, Supriya, your background has gone white. It's not the same as the one that I'm using.
Right. Check.
Your Zoom background I was talking about, yeah.
Yeah, is it? Yeah, as soon as I share, right, this goes off actually. So I'm not doing anything else other than sharing.
Oh, okay.
Yeah, as soon as I share, right, this looks like this.
Okay, no worries. Shall I start the webinar?
3 minutes ago, right? We can start. Yeah.
Yeah, 2 minutes to go. You can put that in presentation mode.
Yeah.
Okay, I'm starting the webinar. It will be on the first slide, yeah.
Yeah.
For those of you who are joining in, a very warm welcome to the webinar. Thank you so much for being here with us. We are still to go for 3 o'clock. There's 1 minute left. We have started earlier. So we are giving some time for people to join in, and we will begin shortly. This webinar is also being live streamed on YouTube. If YouTube is your source of information and you follow us on our channels, you could easily view this webinar on YouTube as well. If you're comfortable here, you're very welcome to have your information from here as well. A very warm welcome to all of you who are joining in. So, Supriya, I think we should begin. Hello, everyone. Welcome to our webinar that we host every fortnight. We bring to you a lot of information on emerging technologies, how to build your career, how to build your resume, and a lot of other stuff that you keep following about us for. And for today's webinar, we have another one. Another informational and another insightful webinar that we are doing today. It's on the topic building generative AI applications, fundamental concepts, practical building, and real world impact. I'm Hina Kausar. I'm Deputy Manager with ITES Sector Skill Council, NASCOM. And today's webinar with me is we have an esteemed speaker with us, Supriya Raman. She's a Senior Vice President, Data Engineering with JP Morgan Chase & Co. And she has 18 years of experience at various firms that she has worked with. She has worked with ANZ, Levi Strauss, and currently at JP Morgan Chase. And she has this exceptional hold on data analytics, strategic leadership, innovation, and driving excellence in these areas. So for today's webinar, we would be along with Supriya. Supriya would be taking us through various aspects of generative AI applications, including the word that we often hear but we are not clear about, including natural language processing, deep learning, all those details that we often come around but we are not sure around. At least that's the case for me. All of this information is quite we read about it but are not sure how to go about this or building a career in Gen AI. And for most of us who are into communication, who are into our professional jobs, who are students who are currently pursuing their education in colleges, we do understand that generative AI is changing the landscape as we know it, and it's being used from generating content to generating voice to generating even our videos and images. And for each one of us, it's confusing if Gen AI would be applicable in all of the areas of our jobs and our professional lives and the careers that we would be pursuing. So for all of that information and to eliminate all the confusion that we do have about generative AI, we have Supriya Raman with us. Supriya, sorry for taking so much of time, and I welcome you on board to this webinar. Thank you so much for being here with us.
Thank you, Hina. It's a great pleasure to be on this platform, and thank you for the introduction. Without wasting much of the time, I'll start with the topic. As Hina mentioned, today we will be exploring more of how we are building applications with generative AI, and talking about the agenda which we have today. We will start by understanding what is text. Basically, if you have to do anything in generative AI, which is more of the text, then what is text behind and why it is so complex to understand a text? Why do we need generative AI? That is the first thing. All the large language model which we have in the market today is based on transformer, the encoder decoder architecture. So we will quickly touch on encoder decoder architecture and the transformer architecture. Then we will talk about generative AI lifecycle. If we have to develop a project end to end in generative AI, what will be the different phases that we will explore through? Also, when we are using generative AI, there can be different flavors of it. You can do it using prompt engineering, you can do it using RAG, you can fine tune the model further, or you can also use RLHF, which is reinforcement learning using human feedback. So we will explore through all these terminologies. Finally, we will explore the architecture of a Gen AI application, and then we will look into some of the challenges which we have while we develop a Gen AI application. With that, let's start with talking about understanding a text. So when we say text, right, there are different phases of understanding a text. And first phase always, I have divided it into three different phases, and we always start with lexical processing. When we say lexical processing, we divide the whole text into small tokens. Tokens can be as simple as word, it can be even sentences. But the crux is you divide the whole big chunk of text into small pieces, and then you try to understand each token at separately. The best example to explain this is, suppose you have emails and you want to understand whether it is spam email or a ham email. Then how will you go for it? You actually go for the words, right? And you try to catch up those words which might make it very feasible that this is a spam or a ham. And that's what exactly is lexical processing, where you break the text into small pieces and then you understand each token in solace. The second phase of it is about syntactic processing. When we do syntactic processing, it is more about understanding the language. Therefore, the context of the whole sentence make a lot of difference, and pause, which is part of speech of the language, it is very important in this phase. What I mean by part of speech is a particular word, whether it is a noun or a pronoun or an adjective and adverb, it makes a lot of difference. Also, whether a particular word can be subject or predicate or object, that is what we figure out. So we actually put the context of the grammar of the word together, and we try to understand the whole syntax of the sentence together. And the third phase is when you try to understand the semantic of the sentence. When we try to understand the semantics, there is much more processing which goes behind than what has been said. To give you an example again, suppose I tell you that a cat is walking. As soon as I say cat, as a human, in our mind, we can think of an animal who has two eyes and a tail and so on, right? But in my sentences, I have not described cat. And that is what exactly semantic means. Semantic means you have a pre-processed knowledge which help you to understand that text much better than what has been told in the text. And that's why when you are developing a model, we have to supplement this semantic in form of either the general knowledge or domain knowledge or discourse context. Discourse context basically means a same word can mean differently in different scenarios. For example, take a word bank. It can be a financial institution or it can be a river bank. So, as in when we understand text, what we understand is text can be as simple as text to start with, but it has speech, it has phonics, it has lexis, it has syntax, semantics, and finally discourse. And it keeps on going deeper and deeper. And of course, we will quickly brief on what is the traditional way of doing NLP to how we switch into deep learning architectures. So, talking again about the context and the semantics, I'll give you the first example, and this is a sentence here where the semantics of the, because the semantics has not been supplied carefully, the first sentence itself has been misunderstood. And that's what it exactly means. If you have to really understand the semantics of the sentence literally can mean differently, but if you supply the semantics, then it has a different meaning altogether. Also, the context of the sentence makes a lot of difference. Now, just to illustrate it with example, the first example here is it is a glass of orange water. And if you have to predict the next word, most of us will say it's a glass of orange juice. But how did the word juice came into picture? Of course, it came into picture by the preceding word orange, or maybe because of the word glass. Because if I would have told that she is wearing a orange, then it had not been juice, right? So we understand that the context of the next word prediction, it depends on either the preceding word or some words before. Also, this context might not be as simple as it is in the first example. Taking the third example here, it talks about I met this French girl, Emily, in a conference last year. We fell in love instantly. My parents are conservative, so I planned and organized a blind date with my parents. They loved her. My mother hugged me right after Emily left. Even my dad gave me that rear wink. I'm so excited. All that is left is to convince Emily's parent. Here I am booking my ticket too. And that two actually is, she is a French girl, so he might be flying to France. But in order to predict this next word as France, you have to go all the way back to the word French, which is not even words apart, but it is sentence apart. So, if you have to understand the complexity of the text, it is not only the semantics but also the context window, and we can clearly see the context window are not only restricted to the certain words but to certain sentences also, right? Also, if you have to say, it's not about predictive analytics anymore. We are talking about generative analytics here. And what do we mean by that is when you talk about generative AI, right, it is all based on the base of it is based on neural network. So when we say neural network, basically it is a method of AI that teaches a computer in order to process the data in the way, like in the same way as a human brain understand it, right? You have neurons and you have layered. So in this picture it shows that it has been given a picture of a bird, and then it has been asked in order to predict whether it is a dog or a bird and a cat, and the neural network rightly predicted as bird. So basically it has layers of networks which has been designed just as a human brain, and there is no feature extraction which happens. Feature extraction is not done manually for this. Instead, it is done using the layered architecture which the neural network has already. Also, reinforcement learning. So, in reinforcement learning, what happens is I will explain this reinforcement learning with a quick example again. Suppose you take a robocar, right? So you always have an agent, and there is no fixed set of input or fixed set of instruction which you can give, because if you have to teach a robocar how to drive, there is no fixed set of instruction which you can give and train the robocar. So that agent, in this case a car, will always take an action in the environment, and the environment is where it has been driving in our case. Depending on that, it will reach a new state, and it will also have a reward can be positive or negative. So while it is driving, it might even meet an accident, that is a negative reward. But while it can still go smooth and safe, that is a positive reward, and so on. So in the reinforcement learning, always the agent will take some action in the environment, and depending on what action and what reward it is taking, it will keep on relearning itself. So when we talk about generative AI, it is combination of both. We have neural networks, we also have reinforcement learning. But going back, taking a gear back, we will talk little bit about pre-generative AI era. It is a huge, when we talk about AI, it looks like it's a new buzz in the market. But some of the facts which I would like to highlight here, you can see in 1950 it says Alan Turing came up with the machine intelligence, while in 1955 you have the word AI. AI is not new in the market; it is as old as 1955. Also, today's we are using a lot of chatbot, but if you see, the first chatbot was developed in 1965, and all this buzz came when AI had been made common to us. In fact, it was only in 2018 or something when it has been readily been adapted by the universities, and the courses has come up, and then it became very easy to learn and understand this. And also with the easy computation and the storage which has been available to us now, that these kind of complex problems can be easily solved. When we talk about traditional NLP, there are several steps which we take. You first tokenize the word. So when you say tokenize, it is basically breaking into small pieces. Also, there are a lot of pre-processing of the text which you have to do. So words like, you have to remove the stop word. Stop words are extra words which are the grammatical context of the word, framing of the sentences. You have to remove the stop words. You have to do stemming and lemmatization so that you can reduce the bag of word, and then you create a bag of word. Bag of word, as the name suggests, is extracting the important entities in your text so that you can process it further. And then there had been different ways by which you can create a bag of word. To start with, we had one hot encoding, you had count vectorizer, TF-IDF vectorizer, and so on. And finally, you create the word embedding. So this was all in the traditional NLP. But with the rise of large language model, when the large language model came into picture, the whole scenario has changed. And to talk about the roadmap of how it started, the whole buzz came when chat gpt came into picture in 2022. But if we see the journey of large language model, it actually ranges back in 2014 when we had GAN models. And the actual paper, which is the base of all the large language model today, is based on attention is all you need. This is a paper which had been published by Google in 2017. It is transformer based model which came in 2017. Soon after, we had GPT-1, GPT-2 in 2018, 2019, GPT-3, and now we are on GPT-4. So this is And of course, this is only the journey of OpenAI. Now we have model from almost all organization. We have different type of model, different domain specific model, and so on, different task specific models. So talking a bit about attention is all you need. This is a base paper. And of course, when you had this paper, right, this is the first time when the transformer model was introduced to us. What this transformer model actually means is you have a set of encoders and a set of decoders. So it always says that you have a set of encoders on the left side, and then after the input will pass through the encoder layers, it will create an embedding which will be fed back to the decoder, and the decoder will give you the results. Not going into detail of it, what I really want to show you is what is generative AI. So when we say generative AI, it is no more prediction which is being done onto the existing data, but you are actually generating the data. When we say generating the data can be anything. It started with text. Now we can generate images, we can generate sounds, we can generate audio, video, and whatnot. What are LLMs? LLMs are large language models. These are large language models which are pre-trained on a huge amount of data, and the data can be of different ways, different dimensions. And then these models, once the model has been trained, then they are specialized to do a wide range of activities for us. And we will see some of the use cases in a short bit of time. But what are those activities which it can perform for us? Like summarization, machine translation, and so on. So, if you have to do as is these tasks, you can just reuse this large language model, pre-trained model, and you can do this activity. But at the same time, if you want to do something very specific with the large language model, then we will explore further words like prompt engineering, RAG, and so on in the further slides. So the question comes, are all large language model generative AI? No, all large language model are not only used for natural language generation, but it is also used for natural language understanding, which is NLU. So it can be used for sentiment analysis, it can be used for classification and whatnot. And broadly, if I divide the large language model, there are two specific kind of models which we have. We have transformer model, and when we say transformer model, they are primarily text. And we also have diffusion model, which is primarily for images and for videos. So before we proceed, let's talk about some of the use cases of the transformer model. This is when I say transformer model, these are all large language model, and it all started. In fact, the whole experiment which was being done initially, with which the transformer model came into picture, was done on machine translation. So the first models which has been developed using BERT were being developed in order to do the translations, machine language translations. But there are a list of wide range of tasks which these languages, which these models can do. And to start with, you can have something like essay writing. Essay writing is a very generic word, but if you have a short topic, right, and if you want to generate something out of it, suppose you want to create a PPT on generative AI, right? You take help of Gen AI, and then you can do that. So any kind of content creation can be done. That is the first use case. We can also do summarization. If you have huge amount of knowledge repository, but if you quickly want to understand what is written into it, instead of reading through it and then trying to understand it and then summarize it, you can quickly provide that document to large language model, and the large language model can produce a very effective summary for you to understand through. We talked about language translation. In fact, language translation is now being extended for the local languages now. Of course, we had a standard language translation always there, but now they are trying to extend it to even to the local languages, so that you have the translation available even for the very local languages which are available, so that people can easily understand through. And that's where also we are utilizing LLM for the information retrieval and also to invoke API. And there are a lot of use cases. We will explore some of these in our upcoming slides. So as we say, the transformer architecture, we always have encoder and a decoder. And this is an example which is for the language translation. If you have to do the language translation, you will give a sentence. It is just taking it very simple. It is just giving a sentence, but it can be a paragraph, it can be a document, and so on. So you feed it to the encoder. Encoder will create the representation, and the representation will be fed to decoder, and decoder layers will actually give you the output in the translated language. So this is basically the very basic encoder decoder model which had been developed. But as you can see, you have different variation of this. You can have encoder only model, you can also have decoder only model, or you can have both encoder or decoder model. And all of these have different purposes. We will see in the next slide, which is following. This is the first model. When we talk about large language model, it always start with BERT. So BERT is an encoder only model, and if you see, it has a stack of encoders. And of course, we have stack of encoders and stack of decoders, because we can understand that text has its own context and semantics. And in order to understand that complexity, it cannot be done with a single encoder or single decoder. And that's why we have stacks of encoder and stack of decoder in order to do the same task. So if you see the BERT model, it had, transformer paper which has been published in the beginning had been published with 6 encoder decoder layer. While when the BERT came into picture, BERT has two versions, BERT base and BERT large. BERT base came with 12 encoder decoder layers, and BERT large came with 24 encoder decoder layers. This is in fact, this is not even a recent picture, but of course, it talks about many of the important large language models which we have in the market. You can see very clearly that all of the base of all these models are transformer architecture, but we have encoder based architecture. If you see encoder based architecture, they are mainly used for sentiment analysis or classification type of task. And we have different variation of BERT. So you have BERT, you have distal BERT, robota, and so on. Also, we have decoder based model only, in which we have the generation based model. And it all started with OpenAI, where we have GPT 1, 2, 3, and GPT Chat, GPT 4. And soon, Meta, Google, Microsoft, everyone came with their own models. And also, we have encoder, decoder, both. It has both encoder, decoder layer. And such models have been released by Meta and Google, where we had FLAN T5 or, BART kind of models. So one important aspect, if you see in this encoder or decoder based model, is they have self-attention mechanism, and this is a very key aspect of understanding why these models are very different from the earlier models which we have. When you talk about attention mechanism, right, it is related to human intelligence, how we have how the brain works. It is a cognitive process, right, how our brain works. If you have to really understand a particular thing, then you focus on that particular thing, and that is what is attention. So if you see this example, right, there is a sentence like, a dog ate the food because it was hungry. Now if you see the word it in the sentence can would have referred back to the word food, or it would have referred back to the word dog also. In this case, it actually does not refer back to food, but it refers back to dog. And this is what is attention, where if you are trying to create an embedding of a particular word in a sentence, it does not only depict that particular word, but it also depict its relationship with the word which are preceding it or word which is following it. And that's why, in order to generate this kind of embedding, of course this is a costly affair, but this is what self attention is, where the embedding, it includes the context of the whole scenario rather than just representing the word in solace. Also, there is positional encoding. So you have the embedding of the word, plus you also have positional encoding. Of course, the positional encoding means that what is the position of that particular word in that sentence. But it is not as simple as just indicating the position as 1, 2, 3. Rather, it is either the sine graph or the cos graph which we use. And once you generate this positional encoding, then you add it with the actual embeddings in order to generate the final embeddings. So the embedding which are generated using the transformer model are actually enriched because it not only represent the word, it also represent the context, the semantics, and the complexity of this text. With that, coming back to the agenda, we discussed about understanding the text, and we also discussed about the transformer architecture. Going forward, we will start discussing on generative AI life cycle. So if you have to, if you have to generate, if you have to develop an application in generative AI, what will be the different phases? What will be the different phases, and how will you go through developing that application? That is what we will figure in this section of the session. So if we talk about LLM framework, right, we did talk about lot of models, and we saw that it all started with OpenAI GPT models. We have a lot of other models which came from Google, Meta, and many of the other organizations. Also, we have open source model. Open source model means not only that a model is available for you, but the source is also available so that you can tweak it, you can modify it, and you can work on it in order to amplify it for your own requirements. The important thing to understand here is because these are pre-trained model on a huge amount of data, these kind of processing cannot happen on a simple machine like CPU. Therefore, you need bigger machines. You need, of course, GPUs. And in order to do the LLM inference, you need VRAM. So, of course, we have we need better computer hardware, and therefore, many of the industries like NVIDIA, Google Cloud, AWS, they are constantly working on upgrading the hardware itself, because unless you have those kind of hardware available, you will not be able to process through. Also, in order to process it, as I said, you need GPU, and having such big GPU machines on your on-prem is a costly affair. Therefore, we mainly do such kind of processing on Google Cloud, on cloud platforms, and there are several cloud platforms which are available for us, like you have AWS, Azure, Google Cloud, and so on. We have end-to-end applications which are developed on top of these framework, and there are a lot of applications which has been developed, which may be domain specific, the health specific, and the banking specific, and so on. So if I talk about generative AI life cycle now, if you have to develop a model end to end, then there are 4 different phases, and we will talk about each phase in separately. So we always go with the scope. When you are defining the use case, it is very important to understand that what you are trying to do with the large language model. So always with the large language model, the whole primary objective is always the token generation, right? We are always trying to generate the next token, but the generation of the next token, we have to be very specific what it is utilized for. Just to give you an example, suppose you are developing a chatbot, right? The purpose of chatbot can be summarizing a text. The purpose of chatbot can also be question answering. The purpose of chatbot can also be to do sentiment analysis, and so on. So in the scope, primarily you have to define the use case. If you have to generate the text, what kind of text generation you are looking for, and what is this use case specifically for. The second phase of it is you choosing the right model, because as I said, now we have so many of the models which have been pre-trained, and choosing the right model make a lot of difference, because if you're not choosing the right model, then you might not come up with the accuracy which you are expecting through. So choose the right kind of model before you actually begin. Once you choose your model, then you have to actually align it or adapt it for your own requirements. And we have 4 different phases of it. We can do it using prompt engineering. We can do it using RAG, which is retrieval augmented generation. We can also do it using fine tuning, or we can do it as RLHF. Once you adapt it, then you actually evaluate your model, and finally you go for the deployment of it. So the most important part, this part is very simple, where you choose the model. While choosing the model, it is simple because you are just loading the model and utilizing it. But further, if you have to adapt and align it for your own requirement, which of these process which you will be actually using will make a lot of difference. And as I said, there are 4 ways by which you can adapt this model for your own self. So we will always start with the prompt engineering. When we say prompt engineering, they are simple text, like it is a simple text, English text, which we give, because you always ask the question to the large language model in the English language and you expect a response. But this English like language, the prompt itself, in order to craft a very specialized prompt, it is a very because the more your efficiency of your prompt will help you to retrieve the best result from the LLM. So while you are defining the prompt, you will see how many different ways we can craft the prompt. The second phase of it is about RAG. As the name says, RAG is retrieval augmented generation. It has two phases, and it is always, you have to first retrieve the data. It is ingestion of the data. So on, we understand that large language models are pre-trained on huge amount of data. But suppose you want to supplement it with some extra data, right? Suppose I'm have to do a recommendation, right? And I have to do a recommendation for my product. So I have a document which is very specific to my product, and I want to provide that product specification document as a supplement. Then I can add up RAG, because I can do the retrieval of that document, and then using that document you can do the augmented generation. We will see different versions of different flavors of RAG again ahead. Also, fine tuning in both these versions, right? In prompt engineering or in RAG, you are not touching the base model at all. You're trying to tweak the nature of the model by the external facilitation. In prompt engineering, it is only prompt. In RAG, it is enhanced context which you're providing. But in fine tuning, you actually go and try to change the weight of the model itself. What do you mean by go and try to change the weight? So we saw that LLM models are actually based on neural network. So it has a huge set of weight and bias which has been stored. Now, if you want to train the large language model on a particular domain, or if you want to make it very specific for a specific reason, then you can fine tune it. You can actually go and tweak the weight and the bias of the model itself, and then you can fine tune it for a very specific purpose. And the last one is, of course, pre-training. When it says pre-training, it means that you are trying to train a LLM from scratch. When you're trying to train a LLM from scratch, it is a very costly affair, because first of all, you need such huge amount of data. And the best example of pre-training can be Bloomberg GPT. If you would have heard about Bloomberg GPT, it has been mainly trained from scratch on the financial domain data. So if you have such amount of data and you have such amount of processing and the GPU and the support and the storage available, then you can always train it from scratch. And as you can see, all these four aspects can always help you to make the best utilization of the LLM model. But as and when you proceed from the left to right, your complexity will increase, and so will your compute intensiveness. Okay. So if you see, you always have a base model to start with, but you can, on a specific knowledge base, you can fine tune the model, or you can use RAG. In both cases, using the base LLM, you can fine tune the LLMs. Okay. With that, let's talk a bit about prompt engineering. So as we said, we always have a LLM model, and the input which you provide to LLM model is in an English-like language, right? So in this case, you are giving some English-like language, and this is the prompt, and that's why it is also called that English is now our new programming language. And LLM model will take this prompt, it will process it on its own predefined model, and then it will give you the completion, which is basically called a response. In this case, it is basically giving the sentiment, because we are asking for the sentiment. And then there are different tweaks which you can do with the prompting. The prompting can be as simple as it has been kept at the first half of the slide, but then you can tweak it, and then you can, amplify it with different version of prompting. So here it shows that it can be zero shot. Zero shot means you're not giving an example, rather you are just giving a prompt, and then you are expecting an output from it. At the same time, you can also have one shot example where you can, before you ask any question from the LLM, you are actually giving an example to it. So you are saying, classify this review. You gave a sentence and you said that this sentiment is positive. And then you are giving a second sentence and then you are asking sentiment. So it is basically giving it, supplementing it with some kind of example so that it can give you better response. And if you can also have few shots of prompting where you can provide more than one examples. Also, you have chain of thought of prompting. Chain of thought prompting is basically used when you are doing some mathematical kind of problem where LLM are not well versed in order to give you the output as is in one go. So you can always tweak your prompt in order to say that go step by step, or do the processing step by step, or you explain the process and so on. So if you do such kind of chain of thought processing, you will always expect a better response from the LLMs. We will talk about a RAG. We talked about RAG and we said that it is a retrieval augmented generation. So I have given different versions of RAG which we are utilizing. So if you see the first picture here, it shows that we have a user. It throws a query onto the model, and model is giving a response on the back. This is the traditional LLM which we talked about, right? So if you are just using prompting, then you have a prompt, and prompt is submitted to the large language model, and the large language model will give you the response back. But if you talk about RAG is basically enhancing the context. So you will have some kind of external memories. When you say external memories, it can be documents, it can be databases, table, chatbot, Confluence pages, Jira pages, or whatnot. Any external kind of memory, you can retrieve the data. Basically, you have to ingest that data, and that ingestion of the data along with the query of the user, query means prompting, is now being supplied to the LLM. So now LLM does not only have the query which the user is submitting, but it also has been supplemented by external memory, and together that is submitted to the large language model, and then the large language model will in turn return you the response. This is the most basic RAG which we can have. But this external memory which we are talking about can also be as complex as tabular data. In case you have some tabular data, or you have databases to connect, then it will not, it will ingestion will not be as simple as the first picture. So the third picture here, it shows that you might have to put in between the models like text to SQL or SQL to text or so on, because you have to convert this text into SQL first, and then this model, in addition to your query, will act as an input to your LLM model in order to generate a response. And the last bit of it is also agentic RAG. When you say agentic RAG, then the LLM is not only making it is not only giving you the response, but it also taking some amount of actions based on what is your prompting. So example here says that what is a summary of Meta GPT document? This is a prompt which has been submitted to the LLM, and you can see that actually the prompt passes through the router. So the router will make a decision, right? Sorry for that. Router will make a decision whether it is a question answering kind of query, or it is a summarization. In this case, because it is asking for a summary, you can see that the agent has actually taken a route, and it has gone through the summarization, and it is generating the summary index, then it is going through the LLM in order to generate. So when you have agentic RAG, it is not only about enhancing it, but it is also some amount of actions which the LLM can take along with the response it is generating. We will go to the further layer ahead, which is about fine tuning. And as I told, fine tuning is always about tweaking the weight of the model itself. So in both the previous examples which we saw, the prompt engineering and in RAG, you are not touching the base model, the LLM model. You are using as it, but you are only supplementing it with the extra context. But in fine tuning, if you really want to enhance your model for a particular task, or for a particular domain, or for a particular enhanced particular kind of specialized work which you wanted to train it, then you can actually fine tune it using your own public data set or a personalized knowledge repository. And the best example of the fine tuning is your PEFT model, parameter efficient tuning, in which you always have the base weights, and in addition to it, whatever is your personalized repository, right, you also generate extra weight. The base weights are always frozen, and on top of it the extra weights are calculated, which in turn is freezed together with the base weight of the LLM, and then that is used in order to do the further prediction. The example of the PEFT model is a LoRa model, and we are using LoRa model a lot for fine tuning our task. And the last bit of it is RLHF. RLHF, as a name suggests, is reinforcement learning using human feedback. And we saw in our previous slide, right, when you talk about reinforcement learning, basically there is no finite set of instruction by which you can train. Basically you learn from your own experiences. We talked about robocar, right? So you actually take action, and based on how your action react on the environment, you have rewards, and based on your rewards you keep on taking the next action. So when you do reinforcement learning using human feedback, of course it is a very costly affair because humans are involved, right? And if you see this example, you have a prompt and the LLM is generating three type of completion, and then you have three different user, right? And each user is told in order to mark which of these the responses are based on the priorities. So each user have marked it differently, with two of the users says that the yellow one is on priority one, while and so on. So basically the response which the LLM has been generating, right? You can use a human feedback in order to label it or you mark it, so that you have the priorities marked, and then once you have the feedback with the human, then that feedback can be fed back into the LLM in order to make a better decision. So the first picture here, if you see, if you talk about the performance of the RLHF model, you can see that with no fine tuning, you had a very less performance. When you did the initial fine tuning, you have a better graph. But if you do the fine tuning using human feedback, you have a very elevated performance. Of course, the performance goes par, and it is very good to have RLHF. But as I said, it is a very costly affair, and mostly because you need people, human, who are trained or very specialized in that particular domain. Coming back to the agenda now, we have now discussed about generative AI lifecycle. We discussed about prompt, RAG, fine tuning, and RLHF. Next, we will go to discuss the architecture of the Gen AI application. And finally, we will conclude with some of the common challenges which we have in order to develop these kind of architectures. So if you see the architecture, right, we talked about prompting, and of course you have static prompts. Static prompt is basically you have simple prompts which has not been specialized using any kind of composition or template, and you keep on enhancing your prompt. So you can have prompt template, you can have prompt composition, contextual prompt, and so on. You can do prompt chaining. And finally we talked about RAG, which is a second method which we talked about. And then we have autonomous agents, and then we talked about fine tuning, and then RLHF. And you see that as and when there is no fixed architecture of the Gen AI model, but as and when you choose these different methods of enhancing your model, right, in the base model, you will have an increasing level of flexibility, but at the same time your complexity will also keep on increasing. And therefore it is always a trade-off where you have to really understand whether the base model, what you really want to do, whether if you choose a base model and if a prompting is well doing your work well and good, but if you really want to go with fine tuning, you can also combine many of these methods, right? You can combine RAG along with fine tuning in order to get a better response. But we always have a trade-off where we have to really understand which of these particular method which we should use in order to tweak the base model for our specific requirements. Now, this is one of the architecture which I picked up from the LangChain paper, and this is a very generic architecture which we are using if you are using a RAG based architecture. So I'll just quickly explain you this picture. If you have multiple documents like this, and of course here it is showing PDF, but you can have the input in any form. You can have any kind of um, input. You can have tables, you can have documents, you can have Confluence pages and whatnot. So any kind of input which you have, the first phase is always to chunk the text. So basically you take this huge amount of text, you break it into small pieces, and that is what is called chunking, which is also kind of tokenization. But in the generative AI, we generally call it as a chunking of the text, and there are different methods by which we can chunk the text. So breaking it into small pieces. Once you break it into small chunks, then you create embeddings out of it. And you can see that for each chunk, we have embeddings which has been created. Generally, we store this embedding into vector databases. In this example, it is showing Pinecone, but you have many vector DBs which are available. Like you can use ChromaDB, you can use Facebook AI, semantic search, which is FAISS, and so on. So you have many specialized databases which are specialized in order to store the vectors embeddings. So you store it into vector embeddings. And then if you see, here is our user at the top, and it is giving a prompt. The prompt is as simple as it is asking, what is a neural network? So this prompt again is then converted into this question, or the prompt is converted into your prompt embedding. So you have a prompt embedding generated, and using this prompt embedding, you actually do a semantic search onto the embeddings which is stored in your vector DB. Once you do the semantic search, you come up with the ranked results, because it, the in the vector DB basically it's an indexed content, so it will give you the ranked result. Using this ranked result as an input to your base LLM, you finally generate the answer, which has been then given back to the user. And this is the most basic architecture which we have for the RAG model. Now, talking about some of the challenges, which very common challenges which we have with the LLM models. To start with, when you have to evaluate the LLM, right? It is a very big challenge. It is, how will you evaluate whether the generation, because it's all generating, right? It's a new content which has been generated. So how will you evaluate basically that the generation is correct? And there are different aspects of even evaluations. To start with, the first aspect is how will you assess that the answer which has been generated is actually safe, accurate, reliable? If you see here, there are different metrics which has been taken. So it talks about answer correctness, it talks about relevancy, semantic similarity, faithfulness, and so on. And basically, if you see the model, it is taking Minster 7B. Minster 7B is one of the large language model which we have. So the first column here, it shows the Minstrel 7B, the base model as is, while the second column talk about the fine-tuned version of the Minstrel 7B model. The third one is about Minstrel 7B model plus RAG, and finally we are using both fine-tuning plus RAG, both, right? And you can see for each of the metrics which we have used, the metrics actually keep on increasing. Finally, when you are using fine-tuning plus RAG, you have the best metrics. So of course, if you have to assess it, you can, assess it into different versions of what we have talked about. Again, keep it in mind that if you are using both fine tuning and RAG, it is a more complex scenario where you are, it is a compute heavy system basically which you are creating. So there is always a trade-off between whether you have to really go with fine tuning or RAG and you need such high accurate metrics, or you can, you are happy with a lesser accurate metrics, but it is a cheaper affair. The second one is of course related with the cost and the latency, and in fact, as I told, none of these model can run on CPU machines, so you always require accelerated compute, huge machines like GPUs, and for inference you always need VRAM in order to load these kind of models. So it is very important that we keep a track of the cost and the latency, and that itself is a very challenging affair, because you have to keep track of how your memory or how your storage or how your compute is being utilized in each of these versions. The third aspect of it is about developing it responsibly. And when I talk about responsible AI, it is a science in itself. And of course, all the major organization have come up with different meaning of responsible AI. But when it comes to responsible AI, we are basically talking about how how responsibly you're developing it. Basically, while you are using it, are you introducing any kind of bias? Are you generating the response which is fair for everyone, and whether you are keeping into track of the privacy and security of the intellectual properties and so on. And finally, we have model enhancement. So we talked about all these aspects, right? We talked about prompt engineering, fine tuning, RAG, and so on. You can see that if you have to optimize your own large language model, the base architecture which you have to develop, then again, the model enhancement, how will you actually practically deploy? And that optimization itself, you need to evaluate it, because every time when you evaluate it, then only you will further come to know that how much optimization more you really require. So this is the first scenario of evaluating the LLM, and we talked about responsible AI. Of course, in responsible AI, for each of the prompting, you are trying to assess whether it is really helpful or honest or harmless, and there are different pillars of responsible AI, as we talked about, right? It is fairness, transparency, and in fact, we have to develop as data leaders, we have to develop metrics around each of these pillars so that we can measure all these aspect of responsible AI effectively. And the final bit of it, which I want to talk about, is LLM inference optimization. Basically, if you have large language model, and I talked about, you cannot process it on CPU or small machine. You of course require VRAM in order to load it, and GPU machines. So there is also a effort in order to optimize the inference time, right? And there are different methods which we are utilizing for it. One is, of course, the quantization. In the quantization, what we try to do is, all these large language model are basically, the parameters are represented in 32-bit. We try to quantize this 32-bit representation of each parameter into smaller data type, so that you have a stringed representation, and then you can actually amplify your requirement of the resources. There are other method also to optimize the LLM inference, like language distillation. So in this case, if you see language distillation, you have huge pre-trained model. These can be used in order to train the student or the distilled version. The best example of the knowledge distillation can be with the BERT. We have distilled BERT also, right? So you always have student or the lesser distilled version of the same model, which has been generated out of the teacher model, and then that distilled model is actually used for the prediction. And the final method is talking about the LLM pruning. So if you have to really shrink the size of this LLM, you can also go with LLM pruning, which is basically talking about removing the connection of the weights. And this can be symmetric removal of the weights, or it can be even asymmetric removal of the weights. But in either case, when you're removing or pruning the weights, then from a large language model, you are actually trying to generate a pruned or a smaller version of the model. So in either cases, when you're trying to optimize it, this is another challenge which we have, because when, sorry for that. So basically you're trying to generate an optimized version which can, run in a more efficient way with the kind of resources which you have available. With that, I come to the end of the slide, and I'd like to hand over the control to Hina. Hina,
Thank you, Supriya, for giving me the stage back. And I would like to have the controls, because I would like to present, because I need to move the cursors along the screen.
Yeah.
Sure. Thank you so much, Supriya. Thank you, Supriya. That was such an informational 60 minutes of our lives, because there was a lot of information to grab and to understand how LLMs and generative AI actually works, especially all of those new information about how AI is not new. It's not 2020, it's not from 2024 or 2000s, it's from way back from in 1955. And all the information about Bloomberg, pre-trained data and the prompting and the architecture, and how we have to, as data leaders have to build responsible AI that are based on the pillars of safety and accuracy. All in all, a very informational webinar that we had today for our audience of men and women, of students, and of early stage professionals. So I would take a few minutes to take our audience through the platform from where they can grab all the information about generative AI. I'm also very happy to announce that we have Google Cloud Generative AI course on our platform live, that they can go to, log in, and complete the course on. So this webinar has been brought to you by Future Skills Prime. It's a digital talent hub for India, and it's a initiative by Ministry of Electronics and Information Technology, METI as we call it, and NASCOM. You can see over the right hand side corner the sign up QR code that you can maybe scan onto your Google cameras, and then go to the channel that I am talking about. Sorry for that. And to make you understand how this works, we have various competency diagnostics. If you're not sure which particular course is meant for you, we have various courses on AI, ML, 3D, on AR, VR, and other Gen AI programs, as well as cloud computing, cybersecurity, mobile applications development, web technologies. Close to 11 emerging technologies we have courses on, and you can assess your competency diagnostics, what your particular aptitude is, and then maybe you can do any foundational, bridge, or deep skilling course. And the certification that you receive at the end of doing this program is both from NASCOM as well as Government of India, Ministry of Electronics and IT, METI. And you also get a lot of incentives, and you can build your skills passport. This will help your career, of course, and this is the certificate that you would receive. As I mentioned, it would be certified by both NASCOM and Ministry of Electronics and IT, and this is the kind of certification you would be receiving when you complete the course. As I mentioned, these are the courses that we have on our platform, including 11 emerging technologies, as well as various professional courses, effective communication, collaboration, design thinking, etc. Very much required and very much in demand. These are aligned with the industry. So whenever you do any course from our platform, you can get credits for your course into your academic curriculum. So whatever time that you invest in building your career, it directly goes to the credit that you can build in your academic calendar. Again, I would like you to maybe, this is the platform, and I would like to give you a short demonstration of the platform. So this is the Future Skills Prime platform. This is the sign up button. Once you click in, I have already clicked onto the platform so that we can log into quickly. And this is my account. I have done a couple of badges. You can see your profile. You can head to the home page. You can select various courses at the home page. And then if you, any badge or any certification that you complete, you can see it in the My Learning, and you can see it in the skill passport that you build over time. It will grant you some points, and you would grab some badges. I have done a couple of them in prompt engineering and ChatGPT, because I do use a lot of Gen AI in my communication profession. And then You can, of course, share these badges on your social media platforms and networking platforms, including LinkedIn. So, quite a lot of detail in a short amount of time for our audience. And now I would like to take a back step and ask Supriya to answer any questions that our audience might have.
Surely.
So I would request the audience, if they do have any question, they can tap in, chat that particular question into the Q&A box that we have over here, or even in the chat box. Supriya would be answering those questions for you. We do have received a couple of questions from the audience, and we have answered them in the Q&A box. They have asked about the skill passport and logging into the platform, and I have demonstrated that via the demonstration that we did for the platform. Any other question that our audience is interested in, they can type into the chat box or the Q&A box, and we would have Supriya answer those questions.
Surely, otherwise, I'm also available on LinkedIn. If you have any queries, follow up also. You can follow me on LinkedIn and we can chat there also if you don't have immediate questions.
Great, that sounds good, Supriya. Thank you so much again for giving your valuable time from the busy schedule that you have. Thank you so much for the informational webinar that you did for our audience. And thank you so much for being here. And I would also like to thank you, the audience, for being such a patient audience and being with us till the end of the webinar. Thank you so much and have a great day, everyone.